Hello everyone, welcome to a brand new episode of Nerds, Geeks and Tea. Today joining us is Rafeeq Mavoor, founder of Scidart. He's a scientific illustrator and he and his team is building a lot of tools to make scientific research smarter and easier and faster. Rafeeq, welcome to the Logo brand once again.
Thank you.
Let's dive straight into the big question in the room. What is scientific illustration?
Scientific illustration, as the name suggests, it's a practice of illustrating research, science. So, as a scientific illustrator, I get to work with researchers, mainly from chemistry, biology, physics. So, I have a background in design and illustration. So, I use those skills to help them create illustrations, drawings. So, if you take traditional graphic designers as an example, so they focus on marketing, they focus on design, they focus on color, typography. So, we focus on the science. We want to communicate it effectively. So, we may not make things beautiful, we make things easily understandable, scientifically accurate. So, first we will understand what is the research, then we will use the tools that even the normal designers are using, like Adobe Illustrator, Blender, and then we will create illustrations for research paper. So that is the goal. So at the end of the day, we will be creating graphics for the research paper.
But let's start out with something even more basic. I already know, but for our audience, what did you study and what is your educational background?
So in 2011, right after plus 2, I got to join ICER Tirunelveli. So it's one of the premier institute in India under government of India, which is focusing on basic science research and education. So we will be going through 5 years of intensive training on scientific research. So it's a 5-year course called BSMS dual degree. So I did a major in chemistry with a minor in biology. So in 2016 I completed.
So is it optional to have a minor or is it mandatory to have?
It's mandatory to have minor, but you can choose whichever subject you are interested. Could be
among how many options?
Biology, chemistry, physics, data science. Now even many ICES have earth science, economics. And so on, data science,
And is it during your course of study at ICER that you decided on your career in scientific illustration?
Yeah, that's actually a long story. So during those 5 years, we got a lot of opportunity because ICER was relatively a new institute. So it started somewhere around 2008 across India. So also ICER Tirunelveli was relatively more younger than compared to other ICES. So the institute was developing, all departments were developing, club, cultural fest, everything was being developed from scratch. So we got opportunity to design, to bring together team, club. So I was more focusing on designs, like creating logos, t-shirt design, designing merchandise for cultural events.
Okay, so you're saying design and coordinating all of this in the process of developing ICER, the institution itself?
Yes.
Okay.
Yeah. So which gave us a lot of opportunity.
Okay.
So now ICER is a very established institute. So during that time, I found a lot of passion in designing, especially in logo designing. So even now, several departments and clubs at ICER Tirunelveli still using the
logos that you design.
Yeah, I design. So if you simply Google Ishia,
it was labor exploitation, right?
Because we were very limited in number. So many opportunities came, along our way. So even after 9 years.
So the initial cohort of ICER students were the ones who built the brand of ICER.
Not the main brand, but all the departmental brands like Chemical Society, Mess Club, Mess Committee, Cultural Club, all those kind of ICER TVM Bikers Club. So coming to the question, so right after graduation, I went back to my professor, just like any other my classmates. I wanted to go for PhD. So I decided to do PhD in material science. So material science is like any material that you see. The battery has some different kinds of materials, energy materials. So in any field, there will be materials. We need to study it in depth, right? So I was working on a certain class of materials which is used for gas storage. So now we know vehicles are electric vehicles. So there is a trend in many countries. vehicles are shifting to hydrogen powered
Okay.
vehicles. So we need a smarter, efficient, cost-effective way to store hydrogen. It's a very big challenge. So during my master's project, I was working on a material which can help in storing gas. So so when I went back to my professor asking for a recommendation for doing PhD, my professor said one of his student was writing a research paper, which she invested more than 4 years of work into that. So she wanted to draw something in 3D, a molecule which forms a very nice DNA-like assembly, which is a 3D structure actually.
Okay.
So she was struggling to create a drawing using PowerPoint. So he said, I know you were a part of this designing and so on. Can you try this? So I said, I don't know any 3D tools, so I can try, I said. So during that time, Google had a software. I think it's still available. Google SketchUp.
Google SketchUp.
Yeah. So I learned that in 2 days. It's a very basic, easy to use software. Using that, I created a 3D structure of that molecule, like actually a molecular assembly.
Okay.
So during that time when I was Googling, I saw that scientific illustration, drawing images for science, is a dedicated career path.
Okay.
So which was a life-changing moment for me. Then immediately I knew that, okay, this could be a really enjoyable career path and a path which I can use my passion and interest. And also I realized that there is a huge demand for people, especially in India. It was a very young industry. Still it is a young industry. So then I went back to my professor and said, sir, I think I decided not to do PhD. Because for me, the decision was easy. Then later I have discussed with my parents and got approval. But when I talked to my professor, he said, okay, this is a good industry. There is a good demand. He being someone traveling very frequently, also someone who is in contact with several research journals, he knew that there is a good demand for people. So he said, okay, just go on, but you need good experience, industry exposure, as well as samples of work that you have done. So then you can get into industry. So that's what the start. Then he gave me an opportunity to work in his lab. For 2.5 years, I worked with him.
Okay, in
Trivandrum.
Okay.
Professor K. J. Thomas. I can't, complete any discussion related to that without mentioning his name, because he's my mentor. Still, he's a mentor. So that was the start. It was 9 years back, and ever since it was a exciting journey. Still, I feel like I just starting out. So much to be done. So much opportunities are there. Yeah. So to summarize, it's a field for someone who has a education in science with a passion for art and design can pursue. Still, there are opportunities.
Why is scientific illustration having such a huge demand in India specifically? Is it not as grown as it is in elsewhere in the world?
Yeah, that is a good question. So when I was starting, I knew only 2 people that when I searched online, as well as when I tried to talk to other researchers, I came to know 2 people who were working as science illustrators. One was botanical illustrator. She used to draw drawings of plants. The other one used to create illustrations of bacteria, microbes, cellular biology, and so on. So there is no path, defined path at that time to become a science illustrator. So the defined path for a science graduate is to either go for PhD or teaching or industry. So that was the huge challenge. So I had to figure things out along the way. So that was the huge challenge. I think still many face the same challenge. So that's one reason we started the academy where we are teaching scientific illustration. So yeah, and also job opportunities were very limited at that time. But now,
for scientific illustrators.
Scientific illustration. But now edtech companies, research institutes, pharma, biotech, and various other research institutes are hiring scientific illustrators. So there are more opportunities. But it was we are somewhere around at least 10-15 years back in this area in India. But it is accelerating. More people are coming forward. Yeah.
So how mature is the scientific illustration space in, say, in Europe, US?
Yeah, it is very matured, especially in Europe and US, as well as Canada. So it's there are many people who with industry experience, same as professors, in any industry working as science illustrators. So there are studios focusing on scientific illustration, focusing on branding and marketing of science-backed companies. So it's a very well-paid job, and it does take a lot of skills apart from the research experience and education. Yeah, so it's a very established field outside India, but outside India the competition might be slightly higher compared to India. But
so before the scientific illustration industry took off, how was this lack of scientific illustration solutions, how was that problem solved, how was that addressed in the scientific research landscape altogether? Would scientists and researchers use rudimentary tools available for themselves by themselves, or what was the other solutions?
So yeah, that's a big problem still. But most of the researchers use PowerPoint. So PowerPoint is the
PowerPoint to draw. Okay.
So I can confidently say that no one has explored the possibilities of PowerPoint as much as science researchers, because they have explored all the possibilities.
Okay.
So the mind of a researcher is like it's more conservative. They don't want to explore much
or new tools
because they want to put a lot of focus into their research work.
Okay.
So that's how it's a critical, logical mind. It's not so much of exploratory outside the bounds of what is defined. So that's what I realized. So there are tools like Adobe Illustrator, they use Blender and so on, but mostly they depend on PowerPoint. But the problem is that they will be busy with academic duties like research experiments, seminar, thesis preparation, writing grants and proposals for grants and so on. So fundamentally the main output of their research is research paper. That's what they publish. When you take a research paper, the first thing you look at is the images, illustrations. So it has a huge impact on their career for sure. So even as a marketing company, you would be spending a lot of time on the thumbnail of a YouTube video. So that is the primary touch point that the person on the other hand see. What is there inside? So similarly for a research paper, to see what is there inside, there will be a small graphic called graphical abstract. So it's a small thumbnail kind of an image, but it need to be minimal. It need to be effective. We have to take a lot of things into consideration. So again, for that also they use PowerPoint. But that was the main reason we started running workshops regularly. So far we have conducted somewhere around 45 batches. So researchers from all across the world join this workshop. They come in a weekend. We have 4 live sessions, and so we conduct it as a very fun, gamified workshop where they come and relax and pick up a new skill. So I personally mainly focus on Blender, say 3D software. So they use them to create 3D animations, small simple animations, and as well as mainly illustrations. So so that's the thing. So still the problem is there, but it is. But because of so many tutorials, courses coming up, researchers are learning, but they don't have enough time to learn. So we need a solution which is very accessible, very fast, because learning Blender, for example, all researchers may not have enough time to learn that. It will take at least 10 days to get a good hang of it. So we are trying to address that issue as well. So over the past 9 years, I have seen many pain points, small bits and pieces. So we have been putting all together, and we have been working on a better solution, which is a tool, especially for scientific illustration. So I'll talk about that in detail, but it will be very easy to use. Anyone who doesn't have science design background from science can simply create graphical abstracts, figures in the research paper. So one thing that we have successfully solved is creating 3D visuals. So researcher has to spend some time in learning a 3D software. So we have integrated a 3D editing studio within that software. You simply click a button. So you have a library of 3D models of materials like polymers, battery materials, crystals, proteins, and so on. So you simply drag and drop it. You arrange the colors, orientation. Then you simply drop that into your canvas, and you can use directly that in your research paper. So we can confidently say that it will save at least several hours to several days of work for a researcher. So yeah, so from the beginning itself, I took this field as a career option by simply trying. So this is what my thought process.
Okay.
So this is a problem that need to be addressed.
Yeah.
Let's try to solve that. And I was sure that it will be a fun journey because we are trying to combine design, illustration with a relatively conserved, dry area, which is scientific research.
Yeah.
So it was fun, and yeah.
But the what kind of an economy are we talking about here? Because there would be n number of science students who are learning in universities across the world. There would be n number of researchers across the world. So I think there are two sides of this impact. One is the sheer number of adopters of the solution that you're building, given the number of students who are learning science across the world. And second, what I'm more curious is about is the impact it is going to have in terms of how fast it will make research, how fast it will make consequent effects in the industry, in different technological industries, etc. So talk to me more about that. What kind of an impact this time saving, this effort saving could have?
Yeah. So from the very beginning, the goal was not to build a business or build a product. So the goal was to to develop a solution. Like I have seen many research students in ISER Tirunelveli spending weeks in front of PowerPoint trying to visualize their research. I immediately knew that it is not efficient. There is something can be done.
Exactly.
So during that time, me being someone who knew how to use Adobe Illustrator, I got to work with several of those research students. So and even what surprised me more is this institute doesn't have a proper course or any training focusing on this. Basically creating visuals for science. So that was the goal. So I started with what I could do, which is basically working as a science illustrator, directly working with them. And then later I realized, okay, I could teach them. That is more scalable, that is more efficient, so that they can prepare on their own.
Okay.
So which is more effective. And which has been happening over the past 8 years. Then I realized, okay, what next? Like, how can we even take a leverage of that? Like, it is definitely building a software or a solution which can address all these tiny problems.
Pain points.
Yeah. So there are several tools. So if I have completed a research project, I need to plot graphs. I will have some data. I need graphs. I might have some materials or some structures that need to be visualized using a 3D software. Maybe it will look like a 3D structure.
Exactly.
It could be protein, crystals, maybe a device, and so on. I might have some pathways and so on. I can use some 2D software. So at the end of the day, I have to juggle between multiple softwares. So that's the thing. So most of the time, what I have seen, researchers will just conclude it with ineffective illustration that could have taken, that could have been much more effective if they used these all other tools. So they don't have time, they don't have proper learning resources to learn all the tools. So using all the useful features from all the softwares for the researchers and putting them together in one space can accelerate for sure.
Okay.
So speaking about impact, at the end, the best thing that we are confident is it will save a lot of time.
Okay.
For sure. Like for a single research paper, I'm confident that they can save several days. For someone who doesn't have a science background, we designed that tool that in such a way that they don't have to learn about 3D software, rendering, camera, rigging, materials. So that's the thing. So at the end of the day, the biggest asset for anyone is time. For researchers, especially, time is the biggest asset because they have to complete a PhD thesis within 5 years. So all the studies that you have done for the 4 years, it could fail. At the end of the 4 year, you might be taking a new route.
Yeah.
So the time is very valuable asset. So that's even today for me, that's the biggest motivation. Like research is hard. It's a very challenging path. If my solution can make a researcher's research journey more comfortable, more ease, more effective. So that's what excites me and even my team members. So so the impact will be definitely big when it comes to research communication, and also we want to make it as affordable as possible. There are tools which are expensive. Researchers are limited by the funds allocated for various activities. So getting several tools may not be a viable solution most of the time. So that's also what we are keeping in mind. We want to make it as easily accessible. Also a tool like Canva. We all use Canva. It's a design tool. Even even our parents who doesn't have any design background might be able to use Canva.
They use Canva to send good morning messages in WhatsApp, family WhatsApp groups.
Yes. So it is very user friendly, and it has very generous free limit. So that's the line we are also thinking. We want people to adopt it huge numbers without worrying about the licensing or anything. We could make it sustainable and profitable by making some advanced features under paid subscription. But we want to make the tool which we named Lab Canvas.
Lab Canvas.
Yeah, it's a drawing canvas for lab research. A well-known name among scientific research all across the globe in all labs. So that's the vision. It's a bigger vision that we know, but I'm in a position that now the path is much more clearer. So definitely that is something simple, but it was hard, but the impact can be big. Something which need to be addressed for sure.
Exactly, because as we speak about impact, like you said, a 4-year PhD, what without such user-friendly, such efficient tools, what it would take for a PhD candidate to do in 4 years or 5 years could be done, could be perhaps cut in half, could be, the amount of time saved could be so much that the productivity of an average researcher would significantly go up. And the impact you're speaking about, I think, would, translate to how scientific research translate to industry level innovations. So research in general becoming faster, and as a consequence becoming more productive, and that's wonderful. And I mean, so essentially what you're building is a Canva for scientific researchers.
You can put it that way. As I have mentioned, two things that we are always keeping in mind is, one is user friendliness. We want even someone with no background in science create some visuals.
Exactly.
And then it should be as affordable as possible. So Canva is a huge inspiration. I have been following their journey from the very beginning. So there is a tool for biology research, which is called BioRender. So for their journey also I have been following from the very beginning.
Is that a user-friendly platform like the one you're building?
So their platform is user friendly, but it is only focusing on biology. So even while I was working at Novo Nordisk, it's a pharma company, one of the leading producers of insulin in the world. So there we have been using BioRender. I was surprised to see that the team is using BioRender. There I could see that the time which took to create anatomical drawing, the mechanism of how a drug works inside a cell was cut down at least a couple of weeks, because BioRender has very nice templates and so on. So BioRender is clearly nicely addressing one problem, which is health science. So my area of expertise and also the area that I could work is especially chemistry, material chemistry, polymer science, soft chemistry. So this area need a solution like that. So that is the current goal. Address the needs of this field, which is material science, nanomaterials, with a tool like that. Even much more capable than BioRender. The Lab Canvas is already much more capable than BioRender. Our goal is not to focus on biology, but to address a problem that is there in material science, chemistry, polymer science, and so on, medicinal science, medicinal chemistry. So, we started with a one version. So that version was more focusing on a tech stack similar to Canva.
Okay.
So what we realized, we spent almost 9 to 10 months building using that tech stack.
Okay.
So at the end of 9 months, what I realized, we have been following a wrong tech stack.
Okay.
So then we rebuilt everything from scratch using the same features and same functionalities using a different tech stack. That I'm sure that no one has used that tech stack for design tools, which was surprising for me as well. Even when I asked ChatGPT, any other LLMs, no LLMs has not mentioned this tech stack could be a potential option for this. But it has worked remarkably well. We are very happy. It works more like Figma. It's like but it has very potential capability in simulating things. Like for example, what I would say, if you take any plant or any this seashell, you go to beach, take a seashell, look at the surface, there will be some pattern. Then even the shape has some kind of a structure which follows a mathematical equation. So you can actually simulate that, how that shell forms, how the pattern forms. You take any other patterns, like how clouds forms, how various other patterns that you can point out in nature. Everything can be described with a mathematical equation. So that's what we found. Like this tech stack is very powerful and very much optimized for simulating things. So you plug in equations, you can simulate patterns. You can simply create a drawing of how bacteria grows, for example, how polymer formation happens. So we are trying to combine, the power of mathematics into this design tool. So which makes the tool even much more capable, much more powerful. And what we recently realized, okay, this could be a potential tool for mathematicians as well, also physicists, which we never thought of. So, for example, we know molecular orbitals, like it's a complicated area to get in, but simply take, I think anyone would have studied p orbital, d orbital, y orbital. So every orbital has a mathematical equation related to that. You simply plug in the equation, you will get a beautiful 3D structure.
Okay.
So BioRender, any tools cannot address that. But because of this accidental pivot that we took, which makes that very easy. So it will be like combining science and art with the power of mathematics.
Okay. Yeah, I mean, it makes so much sense that the fact that you mentioned pharma industry and how BioRender is used in healthcare industry, health sciences industry. I was my mind went back to the time of COVID, when there was a race happening across the world to build the first COVID vaccine between different pharma companies, and I was imagining the speed in which the research of that sorts to build a particular medicine for a disease, to build a vaccine for a non-curable disease. The speed at which the research and development of such solutions could be accelerated with a tool like this. And it makes so much more sense. I would love to, I want to talk a lot more about Lab Canvas and the tools you're building, but I was suddenly reminded of, back in the day in textbooks, in science textbooks, when we were in, say high school or high secondary, the kind of illustrations that were there in textbooks, be it in NCERT textbooks or other kind of guides or other extra materials that we would read. Where do those illustrations come from?
Yeah, that is a really good question. Those I'm not sure about NCERT, but one of the job of science illustrator is to illustrate textbooks.
Okay.
Even if you take textbooks of MBBS students, medicinal science.
Exactly.
It has very highly detailed anatomical drawings and so on. So I was working as a medical illustrator at Novo Nordisk. So my job was to focus on the medically rich, like scientific illustrations,
Okay.
which is focusing on various drugs. For example, Novo Nordisk has done a trial. Let's take an example of a device that can be used to inject insulin. So everything that they release, they will do a lot of trials. So most of the trials do happen in India, in various other countries. So we will get the data. So we have a team in front of us, like guiding us. So there will be a team of doctors, professors. So they will be taking the content.
Okay.
They will give us content. Our job is to illustrate it,
Okay.
to convert that into drawings, pathway diagrams, graphs, and so on. So so in that field, now even for pharma company, they have realized the need of a professional to do that job, because because they are putting a lot of the things on the line, because if they make a simple mistake in one of the presentation,
Okay.
it will spread across, because they are a medicine company.
Yeah.
If they make a mistake in a presentation, people will think, okay, how can we trust their medicine?
Medicine, yeah.
So they put millions of dollars for each and every meetings,
Okay.
only for making presentations.
Oh.
So we are a team of 25 plus people, only focusing on PPT.
Just for a PPT?
Just for PPT.
Really?
Yeah. So the team has many people, like as I mentioned, science experts, professors, doctors, and so on. So we have a small team of medical illustrators. So we create visuals. So similarly, one of the area that science illustrators or medical illustrators could work is edtech industry.
Okay.
We're preparing educational materials. So if you take any, for example, there is a journal called Journal of Visualized Experiments. I got also an opportunity to work there for 1.5 years. So my job was to create again illustrations for animations. So those videos are used for education. So it's a proper edtech industry. So, and also I have been getting some freelance work for preparing illustration for textbooks. So yeah, so in NCRT textbooks, I know that many things can be improved a lot.
Yeah, of course. I remember I remember this particularly back in 10th standard. I was bored with the poor quality illustrations in NCRT, and just to make the process more fun, I bought a set of books. I think the publisher was S. Chand Publication. You must probably be aware of it. And they had this 4K illustrations of RBC, and I have always wondered, I mean, how realistic, how true to the real structure of an RBC would, for example, be this illustration. So are these illustrations optimized to meet the real picture as much as possible, or are they optimized to communicate what the researcher is specifically communicating in a particular research paper, for example?
Yeah, that's a very good question. And this also reminds me of one of the illustration that I did at Novo Nordisk, which was again a detailed illustration of RBC in sickle cell disease.
Okay.
Sickle cell anemia, where RBC will bend.
Okay.
So there we created an illustration which was very big, as you said. There the focus was on all the things happening inside the cell, like the proteins, the molecules, everything, the genetic material, and there the focus was to focus on those pathways.
Okay.
So there, especially in science, we need to make sure that everything is scientifically accurate, for sure.
Yeah.
Also in research.
Yeah.
But sometimes we focus on one key part, and the rest of the things can support. So in that case, the shape of the cell, which is sickle shaped cell, was not the focus. The pathway was the focus.
Okay.
But at the end of the day, we need to make sure that things are accurate.
Okay.
You can definitely see in many textbooks things are not so accurate scientifically. But we optimize things for effectiveness of communication rather than making it visually rich. Also, we need to make sure that things are scientifically accurate. Yeah.
So there is a room for manipulation to the extent that what is the emphasis of a particular presentation or a particular paper is communicated well.
So if it is for a research paper, there is no room. Like we need to be precise 100%. Things are accurate to the best of our knowledge, and also the data that we have. But there is something called cover art illustration. Like if you take any magazine, there is a cover art. So scientific journals also has a cover art illustration. So There you can take artistic freedom.
Okay. Is that an industry in itself as well?
Yeah, it's an industry.
Okay.
Because most of, like, during the past 9 years, I have, earned a lot. Like, I mean, most of my income, I was sustaining based on cover art illustration.
Okay.
So there you can take artistic freedom. There you don't have to be, precisely accurate. The goal is to generate interest in the audience,
Okay.
to attract towards
It's
that.
basically a hook.
Yeah, it's a hook.
Yeah.
I have seen very, artistic, renderings of many research.
Okay.
Yeah. So
And how far do they go from the real picture for a cover art?
so
Are they wildly distant from the reality?
yeah, if you take biology journals,
Okay.
there are many journals like Cell, Nature.
Yeah.
They have very abstract illustrations.
Okay.
Like very abstract. It
Okay.
could be related to some ancient concept.
Oh.
Some concept of a god in Rome, in ancient mythology,
Okay.
something like that. So they prefer abstract illustration.
Okay.
But-
For cover art.
Cover art.
Okay.
Most of the biology journals that
Okay.
I have seen. But when it comes to chemistry, we prefer to make things 3D,
Okay.
dynamic, mostly focusing on science,
Okay.
not so abstract.
Not so much historic and philosophical. Okay. Is it the case that biology in general has more scope for artistic manipulations even when it comes to book covers?
Yes, but yeah, biology definitely has more opportunities to illustrate things because it has, more. Like if you take even a human body as an example, you can explore several years illustrating different organs, cellular biology, and so on.
Okay.
But at the same time, chemistry also has a lot of opportunities when it comes to materials,
Okay.
And so on. But comparatively, it is very less in physics and mathematics, but their illustrations might be more abstract. But in physics, again, there are many areas focusing on energy and materials. But yeah, so definitely biology has more opportunities. There is a well-known scientific illustrator, Dr. David Goodsell.
David
Goodsell. He was a very big inspiration for me as well when I was starting out as scientific illustrator.
Okay.
So what he has done, he has developed his own visual language, which means he used watercolor.
Okay.
So if you go to his office, you will see several watercolors, brushes on his desk. So what he has done, he used to illustrate cells.
Okay.
If you take a simple virus, for example, we know that it's very tiny, but it has, thousands or maybe millions of proteins inside, like scattered. So it's a very crowded environment. There will be a DNA or a RNA piece of based on the microbe.
A virus is not a complete cell, right?
Yeah, virus is not a complete cell. It's just a package of genetic material.
Okay.
Very simple thing, but it has a lot of proteins. It's very crowded. Like, how do you illustrate that? So it is very challenging. Using 3D software, you can do that, but how do you draw an illustration like that on a paper? So what he has done, he developed a specific style that if you simply Google David Goodsell, you will see very nice illustration. It will look like artistic drawings, but they are actually illustrations of cells. So what he would do, for example, Escherichia coli is a small bacteria. So he will take a small portion of that bacteria and he will study everything related to that. All the electron microscopy data, all the mass spectroscopy data, all data he will combine. Then he will create a summary, like how many proteins could be there in that position, what are the proteins present in that position, how they orient, how much quantity they have, and he will convert that into a very big drawing. So it can be used as desktop wallpapers. It's that much beautiful. So yeah, definitely biology has more opportunities, and also material chemistry, nanomaterials has more opportunities as well. But to talk about that, there are people who work full time as botanical illustrators. So they only illustrate plants.
Is in botany. Okay.
Yeah. So that is a dedicated area. If you are a good illustrator, you could work in museums. You could work in journals as botanical illustrator. So in museums, they have a practice of preserving various plants as specimens. They will also have botanical illustrators. So they will convert that into very nice scientifically accurate drawings to keep in their archives.
Okay.
So that is also a job opportunity. But now being a tech very big industry. Many people have opportunities in that area, especially in biology.
So, I was thinking that despite having a lot yet to be done in the scientific illustration space, I mean, all through our journey of education, be it in school or for the ones who proceed to do science in bachelor's and master's and later on PhD, etc., they have to be thankful to a lot of illustrators who work behind so far to take it at least to the point where it is right now.
Yeah, definitely.
Yeah. So, talk to me more about the industry specifically that would be impacted. So, I was thinking through my mind it was going perhaps when it comes to material science, developing an alternative to plastic. The industries of climate change, the industries associated with climate change, the industries associated with environmental protection, pharma. So what would be the industries that would be specifically benefiting from this extra pace that would be achieved as a result of illustration being made simpler and easier?
Yeah. Generally, society has a notion that there are not much opportunities in science. Like if you are trying to focus on building a business or a startup, but there are so many opportunities in science. Like you could develop so many products, services based on science for science. So, as you have mentioned, plastic, health science, and various other industries. So definitely me being working as science illustrator, and also we are developing the tool, it will definitely help all these industries, primarily chemistry, material science, health science. But to talk about more about the industries, if you take simply proteins as an example, it can be used in various industries. Like we only know protein as something is present in food, right?
To build muscles.
Or to build muscles. But protein is, you can, if you think, okay, if there is a solution for humanity's most of the challenging problems, you could say protein could be a solution. So it that much powerful, that much potent. So what is a protein? So I have spent several hours, late nights, just by listening to lectures, speeches about proteins. Protein is basically a polymer. Like if you take your nails, your hair, everything is protein. But if you take your blood, blood is circulating oxygen, right? We are breathing air, so we need to spread air, oxygen in all parts of the body. So there is a protein called hemoglobin. So hemoglobin will take these oxygen molecules and it will carry around and it will deliver that into cells. So that is the duty of that particular protein. Similarly, there are millions of proteins across nature. So if you take protein which can degrade polymers, big polymers, it might be used for degrading plastic. Plastic, I don't think is at the moment there is as big challenge that humanity facing as like something like plastic. So if you design an enzyme, a protein which could break these polymers of plastic into small molecules, you simply solved that challenge. Then comes the question whether that synthesis of that protein is economically feasible, accessible, and so on.
Exactly.
So that's an example. So if you take any, for example, climate change. Climate change is a very big problem. How can you address that with solutions from science? So definitely data science, AI, everything is emerging. But definitely for many problems like climate change, most of the issues in health science has a solution based on proteins. So if you take the recent developments happened in the field of AI and so on. So Google has been a forerunner in finding solutions for health.
Google has been investing in health science.
Yes, we know Google as a search engine, a tech company, but they have
and now for Gemini
is there. So we only know Google on mobile phones and computer screens, but they have invested billions and billions of dollars in health science. So one of their remarkable achievement is AlphaFold.
AlphaFold.
AlphaFold, yeah. So it is one of the I can confidently say that in this century itself, if there is something which has made a lot of impact, is definitely AlphaFold. What is AlphaFold? So if you take a protein, so it has a 3D structure. So so basically, there are molecules which are called amino acids, which folds like into a 3D structure, which forms the protein. So how do they fold? How do they coil? If you take a bead, that you wear, you can simply fold it and make a rounded shape.
Exactly.
How do they fold? It's a big problem. It is very hard to predict. So Google has solved it efficiently very recently with their team called DeepMind. Google DeepMind is a very big company who like focusing on AI driven solutions for various challenges. So they have developed AlphaFold, which can predict structure of any protein. If you simply plug in what are the beads, individual beads in that protein, the AlphaFold will tell you, okay, this is the structure of that protein. So I'm just giving protein as an example for various industry business and industry startup opportunities. If you take, if you want to understand how much of a big problem that they have solved in using AlphaFold, for someone to identify the structure of a protein, it would take 4 or 5 years. The first structure took 12 years. So AlphaFold can predict within few hours. So over the past 6 centuries, we know somewhere around 1.5 lakh protein structure. So in 2020, Google DeepMind said we have solved structures of 200 million proteins.
Okay.
So that's the pace of development happening in tech, AI, and so on. So which is happening in science. So now being this data set of all the non-protein structure available, so you could build, a new company based on all protein, not all proteins, many proteins, thousands or maybe millions of proteins. One protein can be a full-blown startup, a company. So that's the power of a protein, just as an example. Similarly, if you take any other industries like a polymer, if you take any example, even if this cup is has a material which is a ceramic-based material. So in chemistry, there are many materials which can, again, a single material can open up, multi-million-dollar company. So to give you an example, in our campus, ISEF Tirunelveli, there is a professor. He's working in organic chemistry. So he's well known. His name is Professor Kana M. Sureshan. So he talks on public platforms and so on. So he has developed a material based on sugar. So I created an animation for that particular research. That's why I am remembering it very well. So that it's a white powder. So it synthesized based on sugar, and it can actually absorb oil, like petroleum and so on. So you might be thinking, okay, what is the use of is absorbing oil? If you take one of the biggest problem that we are facing in environment today is oil spill. When a container, a ship container carrying millions of liters of oil, just it wrecks. It just spills all the oil into the sea. So it's a problem that will remain there for decades. That oil
oil which has already been spilled.
Yes. So how do you solve that? So this powder, if you spray on top of that oil spill, it will become gel. So now it is being a solid object. You can take that solid from the sea. It is easier to scoop
and recover.
And recover. So that is another problem, that beautifully can be solved using this material. So those are the lines that we are excited about.
And is this a solution that is already developed?
So yeah, this is a solution that his lab developed, and later he said that Indian Air Force was planning to acquire that technology. During that time, I didn't follow up, but for example, Indian Air Force, if they take up that technology, they might have a rapid response team when this oil spill happen in Indian Sea. So they can go there and spray this powder on top of that spill and scoop up all those things. But then there was a follow-up research. Instead of spraying that powder, they made small beads. So it's a work in progress. It has been a work in progress. So you can, instead of spraying this powder, now you have these tiny balls of papers coated with this sugar. So now you spray this and it becomes solid objects, and it is easier to scoop.
This could be an industry of billions of dollars, because
Yeah.
every country that is keen on solving the problem of climate change, of especially of climate problems within the ocean, oil spillages, pollution from oil rigs, all could benefit from this technology.
Yeah, this is a very simple, small example that we can take. Likewise, there are many other examples that you can take. And yeah.
You were mentioning about Google DeepMind, and I was reminded of the fact that Google had hired Frances H. Arnold, the Nobel laureate in 2018, if I'm not wrong. And I think her research was around directed evolution to engineer enzymes. And now Frances H. Arnold, I think since 2019 or something, is part of Alphabet's board of directors.
Oh.
And does this, I have very rudimentary knowledge to make sense of it. So given what you said about Google's investment in healthcare infrastructure, developing research, so do you think this makes any sense in connection to that?
Yeah, so we know Google as a tech company, but definitely the way forward for humanity is science. Science, when used in any practical field, it becomes technology.
Exactly.
So we need science people in front. They convert science into technology. So that's why we have people, scientists from various fields who lead various disciplines working in these tech companies. So they translate those scientific knowledge into technology. Even the recent Nobel Prize has been awarded to AlphaFold. So 3 scientists who...
Oh, really?
Yeah.
Which year?
2024. Yeah,
okay.
Yeah, last year.
Very recently. Okay.
Yeah, very recently. So it is a discovery of that much impact. So we will never... Similarly, there are, scientists from various fields like, data science, like even psychology, working at companies like Google, developing various technology. So at the end of the day, if you take psychology as an example, the products are being used by people. So we need to understand how their mind works when they are using the product. So that's the line Google thinks. They plan for 200, 300 years to come, not a few years. Or,
not the coming decades even.
Coming decades even. So even the company that I worked at, Novo Nordisk, they have a 100-year plan.
Wow.
Yeah, it's a 100-year-old company, but they have a next plan for next 100 years. So that's the thing. And also, like there is even a company from Kerala itself, to take as an example. Its name is Zara Biotech. So one student from an engineering college, it was his master project, and then that became a company. Then it became then one company from Middle East invested 75 crores into that company, finding the potential. Wow. So what they have done. So one of the problem that they have solved beautifully is nutrition. So if you take ocean, ocean is a resource. It's a bank of so many resources. We only understand it, up to an extent. It has so many things to be discovered. So one thing is algae. So there are several algae which can be used in our food. So there is a certain type of algae called spirulina. So what they have done, they prepared a biscuit. As part of his project.
An edible biscuit.
Edible biscuit. So he used that algae, which can be grown, very fast in ocean environments. And also the maintenance cost is very low, and investment is very low, but it is nutritiously rich. So what he has done, he used that in a biscuit, and people can consume it. So and that company has grown into a very big company now, developing various products based on solutions from biology. So even if
what kind of products?
So for example, they have even a program which trains students to take a resource from biological science and convert that into product. To give you an example, one student developed some hair care oil. So they uh, do a proper research on how there are materials in biology which can enrich hair. Then they will do some study on how they can be converted into a product. So one example that I have seen is they use rosemary. It's a plant.
Okay.
So it is even in literature, scientific literature, it is known that it can increase hair growth. So what one of the student has done, she created a hair care oil based out of that.
Okay.
So that is an example. So similarly, there are many examples that you could see if you visit their website. So what I'm trying to say is, even from our neighboring place, we have a company like that which is discussed among global markets. So in science, I think there are so many opportunities, but the why we are not seeing as much as from technology is because scientific students are more driven towards continuing the research process in academic environment. So that is where people who have a aptitude for business and business acumen with a background in science can build something
Exactly.
really wonderful.
All the examples that you just mentioned makes me think about how much of a deep connection there are for entrepreneurial possibilities and scientific research. And the bridge between two is not that apparent because often the images that people who proceed to study pure science research would end up having only a research as a career and nothing else.
Most of the time, yeah.
But an entrepreneurial spirit and a mindset to build solutions that will make people's lives better is something that is universal. That spans across people across different disciplines and industries. So the examples that you mentioned throw light to the fact that there is a deep connect between pure scientific research and and the industry, and more importantly to build solutions that people would pay for, that would make people's lives better. I was intrigued by the fact that Google could be a healthcare giant in the coming decades. I mean, it's not something that someone would anticipate. And you mentioned all this all the fact that you mentioned about enzymes and engineering enzymes to get specific solutions. It's truly astounding. And I was actually curious about since we mentioned since we mentioned Francis Arnold, I was also curious about CRISPR-Cas technology, which was another Nobel-winning technology. What is actually CRISPR, and what would be the industry level implications, the solutions that could be brought out of it?
Yeah. So we know we all have various personalities, traits, and everything. Most of the things are governed by genes. Then comes environment, but we only know ourselves better once we understand genes.
Okay.
So that's what Human Genome Project has done, which sequenced an entire genome in human genome. So CRISPR, what enables us, it can edit genes. So far, we only know how to treat diseases. Like if it is a disease which is a genetic disease, we cannot do much because it is engraved in the genes. Genes are present in all cells.
Yeah.
So how do you treat a disease, something like that? How do you cure? We can treat, obviously, but how do you cure a disease like that? So CRISPR is actually opening doors towards that. So using CRISPR technology, you can actually edit genes. If there is a sequence, you can edit them, you can remove them, you can replace them. So if you identify in early stage of a baby's development in the uterus itself, there can be potentially a genetic disease. So CRISPR, using CRISPR technology, it is actually still in development. So that could be the future.
Okay.
So you identify the disease. Most of the cases, you might abort the pregnancy. That is very sad. But what if you could edit that gene in the early stages itself, so that the baby being born without any disease and completely cured from that possibility of that disease? So that's what CRISPR opens opportunities. That's why it won a Nobel Prize. It opens a whole new industry of treating diseases. So even one of my relative I know who is suffering from hemophilia. So he has to take shots very frequently. He can't do so many things that normal people would be able to do. He can have pain and so on. So his life is pretty much confined in many ways. So what if there is a possibility of even treating hemophilia? It is a genetic disease. So CRISPR might be opening doors to that. It's, I think, based on the recent developments for something like AlphaFold, we know how proteins work. So many things have been happened. AI is here. AI can accelerate the discovery. So yeah, that's what I understand about CRISPR. Yeah, it's
And is all this talk about designer babies and it's also associated with CRISPR. I mean, it's evidently very useful in treating diseases, but it could also mean that you can, even if there is no disease, even if there is no particular problem to be solved, you can just have a choice of having a particular trait.
Yeah. So that is there, like,
And that is definitely going to be an ethical debate as well.
Yeah, it's a very big concern as also. So, for example, we have done it effectively in agriculture. So we have BT
vegetables,
vegetables and so on. Basically, what they have done, they have edited some genes to have some type of trait. For example, we have very small mango trees, which is giving so much fruit.
Exactly.
Which is not natural.
Yeah.
But we have edited their gene in such a way that it bears fruit in very short time. So we have done effectively in plants. So what if we do that same in humans?
Yeah.
So I'm not a person to talk in depth about that, but it opens a lot of questions. It challenges safety concerns. But unlike developing, designer babies and so on, we could definitely solve diseases. We could definitely solve challenges by editing genes. But obviously we diverge in various fields. Definitely some people will try also trying designing babies.
Exactly.
Like having some kind of character. What if you could emit light in the absence of like if you are in darkness, what if you could emit light?
Yeah.
In principle, you can do that.
Yeah.
There is a protein called GFP, green fluorescent protein.
Yeah.
If I make you in uterus stage being capable of synthesizing GFP in your skin, you will definitely.
Is it the protein that fireflies have?
Yes, it's similar protein.
Okay.
So you can emit light.
Okay.
So that's a very big area, that could open up. But one thing that we can definitely say that the gap between human and machines is reducing. So we are in a phase that that kind of weird discoveries, like weird developments, going to happen. One thing that which I find with a lot of optimism is Neuralink.
Yeah.
Neuralink is a new technology developed by the company of Elon Musk.
Yeah.
So what in the early stages, I have been following the story from the very beginning. So they said their proposal is we will actually reach in a phase that we can actually transform the human consciousness into machine.
Okay.
So that's their long vision.
Okay.
But their recent progress is, like, for example, if you are a paralyzed person, you cannot move your hands and legs. What if you could regain that ability? How can you do that? So basically, we know that moving hands and legs is based on the signals that being sent from the brain to those organs. So if there is some issue in transmitting that signal, you cannot do that.
Exactly.
It might be because of an accident. But if you have Neuralink chip installed in your brain, you can install that chip in your brain and you...
It's an implant.
And you attach a receiver for that signal in your leg, which is paralyzed. So whenever you want to move the leg, it will send the signal through that transmitter to your leg, and you can behave like a normal person. So that is the direction that this technology can go. But recently they have demonstrated successfully that a paralyzed person could control a computer.
Okay.
Like they have implanted a chip, and for that also they have developed a robot. So they want to make this technology available for a mass audience, mass people. So they have developed a robot. So you go to hospital today, you get it implanted in your brain, and you discharge the same day without any pain. So robot will take care. So one example that they have demonstrated, one person who is a paralyzed person, now he can control a computer. They have installed a chip. That chip can transmit the signal through Bluetooth, whatever technology that they are using, to the device. So all of a sudden, that patient can communicate. That patient can interact with the whole internet. So that is definitely, I think, is a very optimistic development happen. But any technology has bad side as well. So
I mean, essentially what Neuralink is doing is to develop an interface between the human brain and the mechanical world and machines and technology.
Yes. So far we have been interacting with machines through hands, coding or maybe manually controlling some machines. But what if we could directly transmit?
What if we could bypass this process of using limbs to interact with?
So what if you could transmit your thoughts as electrical signals into the machines
directly?
So you can simply think. So they have reached that state. If you think about switching on your computer, it can turn on.
Instead of having to move your hands to push a button or to click an icon of an app, just think about it and it'll do.
So it's a weird technology. What if you connect your brain to whole internet instead of so now we have Meta AR glasses here. They recently released it. So you are wearing that glass. You can simply think about things, and it will show the result inside your screen. So you might be sitting silently on some place, but you might be doing intense research. So we are going into that direction. Obviously, as we have owning smartphone, in at least in couple of years or maybe 1 decade, everyone will be owning smart AR glasses. Because it is cheaper. It is very much cheaper now. That is the direction that we are going. It is weird to think about. I would prefer
thinking about the positives.
Sorry.
No, it's not.
So I might be prefer a better future where we are more merged with nature more than. But that's the direction that we are going.
But isn't that inevitable? The growth of, this is a fear that has existed for time immemorial. Because when first computer came and first telephone came, when the first TV comes, and but something about the recent developments in technology makes us think it's a bit more scarier than it was in the past. Because one way to look at it would be to just turn a blind eye towards the potential misuse of it. Because we know that smartphones and any gadgets that we used could be used through malwares to spy on us, for surveillance, etc. Think about having an implant in your brain itself. Even your thoughts could be surveilled. Even your thoughts could be under a radar of surveillance, and that's scary to think about. And what if it ends up? I was watching the movie Black Widow recently. Marvel's. I was much late to watch it. Have you watched?
No.
Okay, so Black Widow is basically about telling the backstory of Scarlett Johansson's character in the Marvel Cinematic Universe. The backstory is that a group of girls, a large number of girls, are abducted by a mafia who basically controls the brains of all of these girls, their neuro movements. And in one of the scenes in the movie has Scarlett Johansson barging to attack the villain, and she's unable to move because her nerves are being controlled in such a way that the moment she smells that person, the moment she gets the smell of that person, her motor neuron apparatus would be disabled. So that a specific person could never attack that person. And what she does is hammers her nose on the table to blunt her olfactory receptors so that she can bypass that problem. And it got me thinking about what could be the potential misuse of Neuralink, where some powers could potentially control entire brains of entire populations, the way people think, etc.
Yeah, that would be the worst.
The worst case
outcome.
scenario.
Yeah,
But it's good to think about the positive outcomes. Parkinson's
Yeah.
being cured, Alzheimer's being cured, or perhaps cognitive disorders itself being cured. I mean, it's good to think about the positive sides of it. Ultimately, entrepreneurship is all about solving problems rather
Yes.
than but it could definitely be. I mean, the technology that comes out of such endeavors could definitely be used for creating problems as well.
Yeah.
And that gets me thinking, like, if you tell me more about some remarkable things that you have noticed in terms of people or enterprises which helps us think positively about the world in terms of the use and the use of science. Tell me more about some enterprises or noteworthy examples you have seen of uh, people whom we can feel optimistic about.
Yeah. So, like there are being someone who has been active in science. So I've been following various public faces like in space, in biotech, in pharma. Like there are many labs who is bringing forward very optimistic research. So I immediately thought about Dr. Manu Prakash. He's a Indian scientist in Stanford.
Okay.
So his research
Where
is
in India is from?
correct location. I don't
Okay.
know, but
Manu Prakash.
Manu Prakash. So he's a very very different personality, and his research is very fascinating. So I've been following his work, for several years now. So what his lab does, for example, there is a problem in society. So his philosophy and approach towards that problem is how can we solve this based on very cheap, I mean not cheap, like very cost effective way, like the things that available all around us. Can we solve that issue with that philosophy?
Okay.
So
Instead of investing on
instead of investing millions first, then iterate on things and then finally create an outcome. So his philosophy is, can we use immediate things that available here and there, like paper, cardboard, lens,
Okay.
scale. So can we use them to find a solution to that? So I think that approach is very, very fascinating. I think all scientists should take that mentality in their research. So one of the things that he has developed is foldoscope.
Okay.
Foldoscope is a very basic microscope, very simple microscope, which is developed based on paper.
Okay.
So you simply fold some paper and attach a ball of ball-like lens.
Okay.
And it becomes a very powerful lens, microscope. So he has, popularized this a lot. It is very well known among science communication community,
Okay.
psycho community, foldoscope. So whenever they conduct a workshop for children, they will have a session on making foldoscope. So that is one simple example. So one other work from his lab is paperfuge.
Okay.
So health is always a problem in remote villages in Africa, for example, Tanzania, Kenya. There are many villages like who doesn't have access to primary healthcare. Statistics are saying there are more than 1 billion people who don't have access to healthcare.
Okay.
For us being living in Kerala, most part of India, we have direct access to healthcare. That is our normal situation.
Yeah,
That's not the normal situation for many people around the world. So malaria is a very big issue in many villages. One of the key challenge in treating malaria is early detection. So you to detect malaria, you have to take the blood and centrifuge it.
Yeah.
You basically spin it in high speed so that you can separate various layers of blood so that you can look at the parasite.
Okay.
So it needs an expensive machine called centrifuge. It basically spins that thing. So when he visited a village, a healthcare center, what he found, he opened the door. So we keep a weight for the door to stay at one position, right? So basically we keep a weight. So they have used the centrifuge machine there.
Okay.
So it is basically not working.
Okay.
So maintaining, so everything is a challenge in villages like that. So what his team did, he developed something called paperfuge. So we all know there is a toy, right? It's like we spin it like a disc with two thread. So we spin it very fast, and we will using this motion so that it will spin faster. There is even a candy that we used to eat. It will have this thread. So what he did, so he did the entire math behind it. He solved everything around the energy dynamics of that motion using physics. So he had very detailed paper on that. So this toy can revolve very fast. So it actually revolves in 10,000 RPM. Like it's very fast. So it is one of the oldest toy. Like people have even discovered samples of similar toys in ancient caves like 5,000 years back. So no one might have thought about using this for this kind of an application. So you spin it for half an hour. Some time limit he has mentioned.
With the blood sample inside.
With blood sample, they will add blood sample in a small tube. They will load in this spinner, basically a paper disc. So they will load this and you spin it for some time, and you will have this vial with all the individual layers of blood, platelet, red blood cells, and everything separate. Then you can use this microscope that he has developed, foldoscope. It can look at this blood sample. So under $1, you can detect malaria. Otherwise, it could have taken hundreds of dollars, maybe thousands of dollars. But the main point is it is accessible. It doesn't need electricity. It doesn't need anyone to take care of. The same example that we talked, that centrifuge machine they have been using as a weight. So they don't need a technician to take care of it. So it is accessible, it is cheap, anyone can do it. So for such a big problem, he found a solution like that. And we can see many problems that could have solutions like that. So there is a trend in science, like make things complicated, make things big, grand. So with this philosophy, it's a very different philosophy. Even they have a course on it.
So Manu Prakash has a course.
Yeah, Manu Prakash has launched a course during COVID time. I have attended it. It's a very nice course. Anyone from biology who have this business interest should definitely attend that course. It's available online. Simply search Frugal Science. So it's a course available on their website. If you simply take that website course, it will teach how to take a problem, how to look for solutions from biology, electronics, and basic physics, and convert those simple elements into a solution. And how do you market it? And everything combined into a very nice course. I would say it is,
Is it a free course?
Free course. I would say you don't have to go for MBA. Once you complete this master's, complete that course thoroughly. You will, if you work on that really well, you can create a product on your own. So that is an example.
Is it as the name suggests, talking about how to do science in a frugal way? Basically.
So I think that term itself is coined from their team. I don't think so in India we call it jugaad, like making things happen based on the accessories available nearby. So that approach is there. So even though the solution might look so simple, they might have done a lot of hard work. Solving the entire physics of that rotating disc is very detailed and very complicated. Even like the student who worked on that is also an Indian. So that is one example. As you have asked, is there anyone who inspires in science, solving problems?
Has he made a business out of it, or is it open source?
He open sourced everything. Like even the foldoscope, everything is open sourced. Even during COVID, he has developed masks and things like that. So that is the approach that he takes. He open source everything. And his approach towards science, what I find is like he's like a yogic person who tried to solve societal problems using science. So his personality is very humble. His TED Talks are available online. It's very nice to hear. You should definitely check out. So similarly there are many labs, but I think Manu Prakash's lab is one of a kind.
Is his personal research on malaria and things around that?
No, his personal research is like that. He is also working on advanced problems, like for example, microfluidics for separating cells. There are hardcore problems he is working on.
Okay.
But one of the main investment of his time and effort is in solving this kind of problems.
Is to frugal science.
Yeah, frugal science. So he himself has said, like, other professors look at him in a totally different way because he is doing something different, totally different from conventional path.
It's interesting because it not only requires an acumen and expertise in science alone, but also an ability to see, which we often speak when we speak about an entrepreneurial mindset. Is the first mindset is to have empathy towards people's problems, to understand what their pain points are, to be observant about what could be potential solutions, what could be problems that be solved, etc. So here the case of Manu Prakash is one where his scientific expertise, scientific acumen comes handy with his ability to innovate with simple solutions that's already out there, like how to convert the concept of a toy into as a replacement for a heavy equipment lab testing. How to use folding techniques to build a microscope. And that's really fascinating. So it's kind of a mix of art, science,
Yes, exactly.
and all of that. And I'm curious about how scalable it is, or how is that microscope something that anyone can build with their hand, or
even if you simply go to Flipkart or Amazon, simply type foloscope, it is available for somewhere around 400-500 rupees.
Okay.
So they are selling worldwide. They have even donated millions of foloscopes all across the world. So if you take as a business opportunity for something like that, definitely it is scalable because they have a patented technology, right? Like how the paper is folded, it's not easy. So he has shown some of the early prototypes that he has built. So it's a challenging problem. Like how do you cut papers? How do you make them work together so that it fits well and it lasts well?
So it's basically principles of origami.
Yes, it is a challenging math and physics problem. If there are equations and all things goes into that to planning how papers should be cut out, and also for a microscope we need to adjust the focal length.
Right? Exactly.
So how do you do that with the paper? So there is some slider that you can pull, basically strips of paper. It can adjust the focal length.
And all of this is made entirely out of paper, probably except the lens.
Yeah, it is like 98% paper, apart from some disc kind of thing which holds the lens, which is I think it's steel, something like that.
Was he specifically inspired by origami techniques and all?
Yeah, definitely. That particular project, foloscope, is an inspiration from origami.
And that, I mean, when you mention Manu Prakash, it makes me think about a figure like Da Vinci, who's into doing multiple things, developing multiple solutions. And what do you think of that interface between art and science and altruism, social commitment, engineering? We when we look at past in pre-modern times, we speak about scholars. They were polymaths.
Yes.
Be it European scholar polymaths or scholars in the Islamic polymaths. From the Arab Peninsula, from West Asia, from Europe. So, what do you think of that? In today's day and age, one would be much more focused on disciplinary, specialized, focused, niche expertise, especially when it comes to science and technology. So, but whereas in the case of Manu Prakash, where there is solutions being developed through simple but clever ways, there is a necessity to have an interface between art, science, and all of that. So, tell me more about your thoughts on how important that interface is.
Yeah, so when I was studying at ISER Tirunelveli, we had a course called IDC, interdisciplinary course.
Okay.
So even modern science is taking that approach in solving many problems. It's not about biology, it's not about physics, it's not about chemistry. It's actually about merging all of them together to solve a problem. So even if you take foloscope as an example, it has physics, it has maths, it has optics, everything is there. So for example, Da Vinci, as you have mentioned, his work is also was a great inspiration for me. There is a book called Drawings of Leonardo da Vinci. I have a book which has a lot of drawings of his work. Many has become a reality. Many.
Yeah, I think the original manuscript of that is owned by Bill Gates. I mean, through an auction, I think Bill Gates. I think so. Yeah.
Okay. So many drawings just remains as drawings.
Okay.
So he is a a prime example for someone who took an interdisciplinary approach towards making something or solving something.
Yeah.
So he was an artist, he was a mathematician, he was a chemist, he was a biologist, he was a medical illustrator, he has done everything. Like for example, one of the earliest examples of medical illustration is from Leonardo da Vinci. So he used to take dissection of human bodies and study all the parts and create drawings of that. He has built cannons for war. Like it's a engineering problem.
Yeah.
So we all know him as an artist who created painting.
Mona Lisa.
Yeah, we relate him with Mona Lisa. So Mona Lisa itself, if you study it well, it has a lot of mathematical intricacies. Even the paints that they use it cannot be developed by someone who doesn't understand chemistry, who doesn't understand pigments, how they can be mixed well together. So he understands the chemistry, the anatomy, the engineering, the science, the physics. So he didn't limit himself to any discipline. He took life, So that approach is still missing in modern science.
Okay.
There is a clear reason for that. When humanity accelerated, when we are moving fast, we cannot afford to have someone spending time on various disciplines. Because we want more people working on
the same. It's an assembly line approach to manufacturing in an assembly line approach to science and research itself.
Yeah. So even the modern education is wired towards that. We want workers, not thinkers or social reformers. So in earlier times, things were not that much progress. So they wanted people to look for all the possibilities. So even the time of Leonardo, there were kings who were his patron, who basically funded his work to build statues based on metal, or build huge cannons or big artworks. So he would spend several months, even years, on particular work funded by these kings. So his work, if you look at his work, he has touched on all disciplines without any barriers. So now in modern science, there are several labs, for example, Manu Prakash lab, if you take an example, taking that kind of approach. But modern science has limitations. When if you are submitting for a funding, you have written a proposal with this approach and you submit to a funding agency, it is very unlikely that it will be accepted. It will not get accepted. They want you to focus on one targeted problem and solve with your entire team and resources. That's how modern science works. But now AI is here. So as we have discussed, Google has many scientists working. Even like AlphaFold, they have open sourced it. So now, as an engineer, as someone working with code, as a computer scientist, you could use AlphaFold technology, which is basically a biology related tech. You convert that into a product or a solution for finding drugs, accelerated drug discovery. So that barrier is now in a phase that slowly dissolving. Basically, AI is enabling more people. It is cutting down the resources need to build something. So that kind of approach is happening. Even Neuralink, if you take an example, it's a very hard engineering problem. It is a very hard electronics problem. It is on top of that, it is even much more harder medical problem. Attaching a chip into a biological tissue is not a small feat. It's your body would simply will not accept anything foreign. In that place, you are attaching a chip even to your central part of your body, brain. Making that possible is very challenging.
Exactly.
So that is another example. So I think Elon Musk is taking similar approach. I would say similar to
Da Vinci.
Da Vinci. He has a boring company to build
Yeah.
tunnels,
Yeah.
which can solve traffic problems. He has a company on building solar panels, so it can solve energy problem. So he has Tesla, a car EV manufacturing company. We know it is one of the leading company in the world, and he has a AI company which is called XAI.
Yeah.
So one of the chat assistant Grok. It is one of the most powerful chat assistant today, LLM, which is very much capable, and he has one of the largest data center.
Yeah.
So he's taking that approach. His plan is to colonize Mars.
Yeah.
So it's extremely difficult, extremely ambitious problem, but he is trying to solve that by building a rocket that can take humanity to Mars. With we don't want to send people to Mars, and if it takes years to reach there, it is not a solution. But his vehicle can go faster. His vehicle can actually capture methane from Mars and convert that into energy fuel, so that you can use atmospheric methane from Mars and come back.
Yeah.
So in his interviews, he say we want to send people to Mars alive, like not just like we don't want them to die on impact. We want to safely
Bring them back
as well, if needed. So which he has proven. If you look at the examples of present development happening from the company SpaceX, they have successfully flown their largest rocket, which is
Not
Starship.
Starship.
It is
Starlink is their network company.
Yeah, it is network of satellites.
Satellites. Yeah. Starship.
Yeah, another company.
Exactly.
So I think Elon Musk undoubtedly is the modern Leonardo da Vinci. He's not into arts, but he's very much into design. I have seen.
And he's very much into controversy, getting himself in trouble, and we don't know how timeless and how long would it sustain. And I don't even know whether to call it plain eccentricity or madness or some smart tactical move to get attention. Don't know where to place it, but definitely Da Vinci is an inspiration in that regard. I mean, the man built, I think, the first diagrams of helicopters, flying machines, and a lot of other things like.
But talking about Elon Musk being controversial, I have been following on of his tweets on Twitter. So I'm sure that he has a strategy.
Okay.
When you create a controversy, people discuss about you. People get to know about you. People get to know about your company, product, your agenda, everything. So it's a genius marketing technique being pulled out very effectively. No doubt about it. So even he mocked people. He published memes about presidents, other political leaders. So that is actually
being the center of attention all the time.
So he's not being an engineer. He's not being a problem solver. He's a businessman, and he's doing marketing effectively. So everything come together, into his skill set. That is very rare. So there we have scientists build great products, but most scientists are not good at marketing. Or bringing their product to the people, talking about their work. Most scientists don't want to talk about their contribution, or they don't want to come into the light of discussions. So they want to be conservative. So that is completely fine. But because of that approach, we lose a lot of technology which could revolutionize various industries. Just because that they are not communicating it enough as much as they should. So basically marketing is communication. So Elon Musk is doing a fantastic job. He has even acquired one of the largest public marketing platform, which is Twitter. So I think he has proven in all areas like that. So talking about design, I have heard that he is very much into UI UX design. He don't want to sell his car with average looking software. If you look at the display of Tesla cars, their UI is very beautiful, very nicely designed. So definitely he's very much into design as well.
Yeah. I mean, it's an important point. I mean, whether with respect to Elon Musk, I mean, I have heard this theory about this being a marketing strategy and him being a genius marketer. But only time will tell whether, because beyond a point, genius becomes indistinguishable from stupidity. It is difficult to say whether it is too much of intelligence or too much of stupidity. So only time will have to tell. But on the spectrum, I'm on the rather optimistic end about Neuralink, about SpaceX, Tesla, and what the impact of those ventures would be. But the point that you mentioned is so important: the importance of branding and marketing when it comes to science. Because as you said, the perception would be that science is something that is so confined into the corridors of laboratories and into that desk of a researcher, which would then get translated into papers, which would take years and decades to come into real life products and solutions that people use. Even when people use those technology and solutions, people wouldn't know the scientific research that went behind it. We all take MRI scans, whenever there is an issue, but people hardly know about when magnetic resonance as a concept was understood in physics, etc. But the reality is that even in pure science research, or translating this research into industry solutions and real life problem solving or products, branding and marketing is so crucial. And I want to hear your thoughts on that, like when it comes to, especially when it comes to science research, how important branding and marketing is.
Yeah, it's a very it's an area that need a lot of help. Like some people like you, like the agencies like you, could contribute a lot. So what I would say, all scientists need not to do marketing. If what I have seen, from the experience of working with various scientists, so they are focused on one problem. So they are wiring their thoughts, skills, everything around that. Marketing is chaotic. It's people, it's the real world, it's dynamic, it's unpredictable. So if they try to do marketing, it can negatively impact their work. But if you can do both, then great. But I would say,
are there people who have successfully done both?
Other people, yeah, definitely. Edison is a great example. He has his story of making bulb. Like he has created 999 examples which failed, and the 10,000th one succeeded. That story still lives because he was a very good marketer at there. He was very successful in communicating that piece of story. So he was very good marketer. So what I would say, at the current landscape of scientific research, there are many labs that could take benefit of marketers. For example, at IISER Pune, there is a incubation center called Adal Incubation Center. What they do, they support all these scientists to take their science to market. If they have found a medicine, for example, a drug molecule, they can help them to get funding to convert that into company, startup, and so on. So those kind of ecosystem is very much needed. So now incubation centers are doing, they can do up to an extent. They are not great at marketing. They can connect you with various people, funding agencies, and so on. So marketing is a totally different ballgame. So as we have mentioned about Edison, we all know Tesla.
Nikola Tesla.
Yeah, Nikola Tesla. I would say Nikola Tesla was very much genius. Very much, he has
even far ahead than Edison.
Yeah, I would say. I think based on his work and the vision that he had across all industries, his work was out of this world. Like even people bring forward conspiracy theories saying that he has some connection with aliens. He got these secrets of nature and electricity from some extraterrestrial communications. They are conspiracies, but the thing is, he has contributed a lot. Even Elon Musk, he named his car company Tesla. We can clearly say, why didn't he name anything else? He is clearly a big, huge fan of Tesla because his work is so fantastic. But he was not so great marketer. If you ask about any scientist, with even to our kids, to our children, they would say Newton, Einstein, Edison, who found bulb. You will hear rarely kids say Tesla.
Yeah.
They don't know about Tesla.
Yeah.
Tesla
Probably people would know the name Tesla from Elon Musk's company.
car company.
Yeah.
So Tesla even had some proposed engineering method to transmit electricity without wires, wireless transmission of electricity. He some records are saying he has a proper documentation for that. It didn't become an actual reality, but if that technology became a reality, it would revolutionize everything. Like you could transmit electricity from one location
to remote places,
to all parts of the country.
And the whole problem of access to electricity would be solved.
Yeah, it's a very challenging problem. There are many questions. How do you transmit electricity through air? But if he would have lived maybe a few more years, he might have came forward something. But most of his work we are using in electricity, in modern all kind of technology, but people doesn't know much about him. Many other people took his science and marketed it and converted into company and products. So that's the thing. I think marketing is a service that many people could offer for these science researchers or science-backed companies. I got opportunity to work with various science companies, like companies who have some product or service backed with some science related product or something. It could be a software, it could be a physical product. So across all companies, one pattern that I have seen is they are not great at marketing.
Okay.
Everything today is led by some kind of presence online. Even Elon Musk, he is on Twitter, on all platforms, not because he want to, but his personal brand need to be present everywhere. Even in this discussion, we have mentioned his name and various other companies only because he is doing a fantastic job
at
of
marketing
and personal branding. So what if companies could help scientists?
And there would probably be research going on which would be potentially groundbreaking, giving a lot of breakthrough for humanity, but due to a lack of marketing, due to a lack of getting attention, it is falling behind.
Yeah, they just remain as research papers.
And Nikola Tesla is a historic example for that.
Yeah. So the atmosphere in scientific research is like you apply for fund, you get money, you produce papers, and then you complete that project. The next thing for you naturally is to get next funding.
Okay.
They don't have time to market this or take this to people. I have seen many potential research papers could turned into a product or company, but they focus on the next thing. For their career, they want to focus on next funding, next project.
Yeah, I think you were mentioning in our last conversation about some company that were developing something about drug testing and...
Yeah. So there is a company based in Bangalore. They created a software for testing drug molecules. Drug molecules means any medicine that you take, the tablets. So traditionally, it would take 15 years to find a molecule, a drug, a medicine, to come into market. There are several phases like clinical trials, animal trials, many other things. So, but now we have AI, now we have AlphaFold, now we have supercomputers. We could test molecules inside our body without actually injecting it. We can simulate the effect of that molecule in computer. So which is called drug design. Like you can simulate the effect of that drug in computer.
Okay.
And you can predict whether it would be toxic, whether it could be effective, whether it could affect other parts of the body, right? We have many medicine. Once we consume, the problem that we are trying to affect will be solved, but it will cause another issues, right? Maybe pressure variations, maybe kidney issues, which we see. But with this kind of these softwares, like we can simulate, then go for the actual production in the lab. So we can save a lot of money, resources, time. So
And did they not reach to the market effectively?
yeah, that is the one problem. So they have a software which they took somewhere around 5 years.
Okay.
Which I found is a very nice product and it has a lot of potential. Till when I got to work with them, what I have realized, they don't even have a single paid user yet. They have a service department also. They were focusing a lot on that, but they could have easily got paid users for this at least few years back. When I visited their landing page, it was not optimized. The design was not optimized. If you visit their landing page, the website, with an intent to try their software, you have to book a meeting. You don't have any images. You don't have any demo. Anything, nothing is there. Even yesterday I talked to them. They said, okay, we can have a meeting tonight. How we can improve their landing page design so that they can get demo users. So we would be surprised to know that they have developed this very potent product, but they are failing at marketing.
So, I mean, this is an issue that is faced, across. I mean, not just in science. I think there are maverick geniuses who are good in building things. It could be a tech product, it could be a software, it could be something, a new discovery in science, in polymer science, like you said, or in people who are good at invention, discovery, doing research, and building solutions, but who do not know how to get to the buyers, get to the adopters of this technology or this breakthrough they have created. And there are these channels that are available, as you said, incubation centers across institutions. There are academic incubations, there are VC funded incubations, which gives you all these opportunities to develop your prototype, build it, market it, take it to the users, etc. And I think that is such an unmet gap in terms of connecting this, connecting builders, innovators, and researchers to users, to adopters, and making successful solutions and businesses out of this. Rafeeq, you are someone who has been building solutions. Before we wrap up, I want to hear about other things that you're building. I mean, I know that you're building an array of tools and websites and solutions for different purposes. Could you give a brief walkthrough of what other things that you're building?
Yeah, so our main focus has been and always will be research, scientific research, and we are also interested in education. So as we have been conducting many workshops, courses, and so on, so we are exploring the possibility of using AI in education as well as in research. So Lab Canvas will solve the problem of creating illustrations, designs, presentations for scientific research, especially for scientific papers. So we have been also exploring using LLMs like Gemini, ChatGPT, OpenAI, and Claude, for example, for education. So we try to develop one workspace for students for preparing them for competitive exams. So the future is personalized learning. So now we know the tuition industry is a very big industry. Students will be sitting as a group in a class listening to a teacher. What if you could have a very capable, very well educated teacher only for you, understanding you very in depth, the style of your learning, the weak points that you have. You might be weak at one subject, or might be strong at one subject, or your learning style follows a certain biological clock. For example, you might be grasping mathematical concepts better at morning compared to night. So a teacher cannot understand that.
Exactly.
But AI can. If you learn, most of the students will be going to YouTube and watching tutorials. But if you can track their behavior, and analyze it, for example,
how their brain function at different moments.
Yeah, so you can test it based on various MCQ tests, or feedback that you take from the students, whether they have understood a concept well or not, based on maybe interactive puzzles or simple games. So you can understand the learning style of that student. Based on that, you can customize the thing. And also, as you have asked this, one of the cherishing moment that I always cherish from my college days is playing games. So there is a game called Command and Conquer.
Okay.
So it's a simple game where
Video
game where you build, you can build buildings, you can build defense systems, you can assign soldiers to defend an area, you can build power plants, you can build airports, navy fields, airport stations. So you can build a territory on your own, a small country, and you will have other teams.
Okay.
You have to grow your country. Also, you will have to defend your country, and you also need to invade other countries.
Yeah.
So during 5th year of our college, we had a lot of free time. We would spend all night sitting in a room, connected all the laptops to same Wi-Fi as a team. During that time, I didn't realize much, but today I'm taking a lot of strategies. For example, allocating resource for you at the same time, trying to get into other areas. It's not a small task. It takes, parallel thinking.
Yeah.
So those kind of approach, those kind of decision making, thinking process, now I realize, that was definitely, that had contributed a lot in my personal, thinking process as well as decision making. So which Elon Musk, he started a school called Synthesis School.
Yeah, I think for his kids specifically.
For his kids specifically, then he opened later to whole world. Now anyone can join. So that is, he realized that personalized learning is the future.
Yeah.
So even my sister's children, all of them has different interests and capabilities. So, but all of them has to sit in the same class, listening to the same topics, same subjects. But the future will be in such a way that based on one kid's taste, interest, and aspiration, you can fine tune the things that they will learn, so that we have better engineers, we have better doctors, we have better politicians. Because we have maximized their interest rather than having a doctor which accidentally came to be a doctor. His or her aspiration want to become an actor, and so they will not perform well. So in the future, we are taking that as a research project. Like we are doing research in using AI in education.
I mean, you speak about personalized learning, and what I was suddenly reminded of was Einstein was someone who used to play the violin while solving math problems, while solving equations. So, I mean, there are these theories about different intelligences, mathematical, musical, motor neuron, this, then, intrapersonal. Some might learn through a conversation better. Some might learn through a mathematical explanation better. Some might learn through, doing things better, etc. So, I mean, at no point can a human teacher, cater to all these individual learning styles, and there is the power of AI would be useful. And as you said, this whole paradigm of converting research, innovation, and building solutions into scalable, adoptable solutions that people that can add value to people's lives, and building economies, livelihoods, and businesses out of it. This whole this whole equation is something where scientific research, technological innovation, and branding, marketing, human culture all has to amalgamate and all has to have an interface with each other. And it's interesting that we could have this conversation, because we look forward to collaborating with you in whichever capacity, because the things that you're building are going to be impactful, and definitely want to
definitely because I have been also following the growth of Logo brand from the very beginning, and I love the quality that you keep consistently for all the projects that you take. So definitely the agency belongs to a spectrum where you are catering to a high value audience, brands which look forward to quality or quantity or virality. So definitely, I hope I will be able to come next year to hire your market team for Lab Canvas.
Thank you. I appreciate that a lot. And we're looking forward to a future where disciplinary boundaries are merging and converging and diffusing, and transactions are possible across different domains of expertise. And that's a optimistic future to think about. So thank you, Rafeeq, so much for joining today.
Thank you so much. It was a nice conversation.
You too.